So this lesson is called The Lovely Ladybug, wow. And we're talking about topic 4.2, which is connecting position, velocity, and acceleration. Okay, so that's what we're dealing with right now, is making those connections. So a ladybug moves along a branch so that its position from the trunk of the tree at time t is given by this equation. For times between 0 and 5 minutes, where S of t is measured in yards and t is measured in minutes. So important, of course, is the equation. The equation is clearly always important. And S of t is measured in yards and t is measured in minutes. The units are really important. So S of t is yards and t is minutes. Okay. So that's what we're dealing with. Find an equation for the velocity of the ladybug. Now we know that velocity is equal to S of t, but before we do any of that, let's talk about what's happening in this problem. So we have a ladybug crawling on a branch, and if I was any sort of decent artist, this would be a better picture, but you're going to have to bear with me. So we have a branch on a tree. So this is my branch, so we can talk about it. See why I'm a terrible artist? And on the branch, we have a ladybug. There's my bug. Let's make her red, because she's a red ladybug. And like bugs do, she's crawling back and forth on this branch. So she's right here, and she's going this way and this way. And so she's just moving in a line along the branch. So very often they talk about position on a line, of a point on a line, moving in whatever place. And so we're going to talk about ladybug moving on a branch. So she's going back and forth and back and forth. And maybe, you could have a ladybug that was circling around the branch. And so you can get some pretty crazy equations here, but it's just straight line motion. And that's really strange. But when we talk about position and velocity and all those things, everything gets a little bit funkier. So find an equation for the velocity. Now, velocity is equal to the derivative of position. So there's my position question. So I'm going to go ahead and do S prime of t which is equal to v of t and so we're taking the derivative. So I've got 2t minus 6. No big deal. Sketch the graph of v of t. Use proper units to label your axes. So my y-intercept is 6, which is right here, negative 6, a slope of 2. And there's a picture of v of t. Now it says to label my axes. So this is time, and this is velocity. It also says to use proper units to label my axes. So again, the x-axis is going to be time, the y-axis is velocity in this particular graph. Time is being measured in minutes. And velocity is measured in yards per minute. Yards yd per minute. So that's what it's looking for, is those kinds of things. What does a negative velocity tell you about the direction the ladybug is walking? So again, the ladybug's walking back and forth on her branch. And sorry about my dreadful picture. I really do apologize for my inability to draw. But she's walking back and forth on a branch that's on the street. And this is a low-hanging branch, so we can see it. But she's walking back and forth. So she's going to the left and the right. Right? So what does a negative velocity tell you about the direction the ladybug is walking? Is she, in other words, is she going left or right? Make your best guess. What does positive velocity tell you about the direction the ladybug is walking? Again, in other words, is she going left or right? So make a decision about both of these. We'll do A first, left or right. And now that we've decided about A, B, left or right. Thank you for making your decisions. So if for this situation, if we're talking about number line movement, right is positive. So a negative velocity means that the ladybug is going to the left. Since it's negative, that means moving to the left. If it's positive, then we're moving right. Okay. Question number 3. At what time is the ladybug at rest, and how do you know? The ladybug is at rest when her velocity is equal to 0. The ladybug is at rest when the velocity equals 0. The ladybug is at rest when her velocity is 0, because then she's not moving. She has no velocity, so she's at rest. So looking at my picture, she's at rest at time 3. V of t equals 0 when t equals 3. And we can do the math with that. We can take velocity way back here, 2t minus 6, and set it equal to 0, and solve for t. We will get 3. Add 6 to 0, divide by 2, you get 3. Or we can look at her picture when she's at rest right there, because her velocity is 0. Moving on. What then is happening for v? What's happening at time t? Find v of 1, use proper units. So we're going to find v of 1. So v of 1 is equal to 2 times 1 minus 6, which is equal to 2 minus 6, or negative 4. Find v prime of 1. What does your answer mean in context? So we want to take the derivative. V prime of t is equal to 2. Since v of t is this equation, the derivative of that equation is 2. What does this answer mean in context of the problem? And use proper units. So v of t is 2. 2 yards per minute per minute. Okay. So what does that mean? So I'm going to go to yards per minute squared over here. What does that mean? Oh, I didn't use proper units back here. I just noticed use proper units. Negative 4 meters per minute. Yards per minute, excuse me. Okay. In context of this problem, so the v of t is the rate of change of the v prime of t, excuse me, is the rate of change of the velocity. So v prime of t is the rate of change of velocity. So the rate of change of the velocity of the ladybug is 2 yards per minute squared it's constant, and the rate of change of the velocity. So if you think about that, just generally that whole phrase, rate of change of the velocity, the rate of change of the velocity is constant, but it is also equal to the acceleration. Okay, it's constant, which means that they're, since his velocity is, the rate of change of velocity is constant while he's speeding up or slowing down or going negative or positive, moving left or right, the acceleration is constant. So he's not speeding up or slowing down. It's actually, I didn't actually do this. V prime of t at 1. V prime of t at 1 is 2, because of course it's always 2. And since it is a positive number, the ladybug is speeding up. Hang on, give me a minute. All right, so I just reminded myself of something I know, but I had forgotten. The ladybug's speeding up or slowing down. So at time 1, his velocity is negative, and his acceleration is positive. And so if you think about that, his velocity is negative and his acceleration is positive. We have two forces pushing against each other. So velocity, actually this would be velocity, v of 1 is a negative number, and a of 1 is a positive number. And so they're pushing against each other. And so since they're, the force, like if you think about wind slowing, you know, since they're pushing on each other, it's slowing down. Velocity and acceleration have different signs. So think about that. They're pushing against each other, which is why it's slowing down. If they were the same, they're speeding up because they're pushing in the same direction. Okay. On another branch of the tree, a worm is crawling at a velocity given by this function, where v is measured in yards per minute and t is in minutes, v of t. Find a possible function that would give the position of the worm. That's a weird question. So we've never done that before. So we know v of t is this equation. Okay, and we know that s of t is something, and that if I take the derivative of s of t, I get v of t. So find a possible function. Well, I think t would have to have been squared to get t, right? And so I would have brought down 2 and times it by something to make negative 4. So maybe negative 2. And then to have 3 here, it needed to be times by something. And there could have been a number over here. Let's say, there doesn't have to be a number there, but there could have been one. We're going to call it a number over there, or some constant number. And any number will do. So you can put 15 here, or 72, or 89, or 1, or 0. But, so do you see what I did there? As I worked backwards, I thought, okay, to get t, I had to have t squared. And so that means I multiply 2 by something to make negative 4. And then to get 3, it had to be 3 times t. t just kind of went away, and there could have been a number here. Looking back at the tops, like looking at this one, see how we have 2, and so then the 5 just disappeared. And that's what's happening here is, when again, we are working backwards. We went from this to that, not the other way around. Okay, are there any questions? If you have any, save them for class. All right, and now it's time to fill in the box of important ideas for topic 2.4. Okay, so there it is. So I'm just going to go ahead and talk, and you're writing these down. Important ideas. Number 1, position is s of t. Velocity is speed with direction, and v of t is equal to s prime of t. Acceleration is equal to v prime of t, which is equal to s double prime of t. If v of t is equal to 0, the object is at rest. If v of t is greater than 0, the object is moving right or up, depending on the situation. So we're talking about straight line things, though it's either doing on a vertical line or it's on a horizontal line. We're not having anything weird, even though the equations can get pretty funky. We're moving left or right, up or down, increasing, decreasing. So right, if it's positive, negative. If it's negative, it's moving left or down. And here's the hard part. Acceleration is positive and velocity is positive. The particle is going faster because they're pushing together. Those two forces are together, and therefore they're speeding up because both forces are pushing the same direction. If the velocity is positive and the acceleration is negative, then the two forces are pushing against each other, so it's slowing down. If the acceleration is positive and the velocity is negative, those forces are pushing against each other and it's slowing down. So it's hard to see it there, but that's the idea. If they're both pushing, they're both negative, then they're pushing together and it's speeding up. Okay, so if they're going in the same direction, it's getting faster. If they're going in opposite directions, it is getting slower. Okay, those are your basic ideas. We'll do the check for understanding in a separate video. Have a great day.